Hi viewers, how are you all? Hope everything is going well. In the part 1 and part 2 of electric current, we have discussed regarding the electric current, electric potential difference, electromotive force, and along with the units in the part 1. And in the part 2, we discussed regarding the Ohm's law, its verification, electrical resistance, and the factors that affect the electrical resistance of a conductor, and resistivity and conductivity along with their units have been discussed. Now coming to the part 3, we are going to learn about the resistors, how the effective resistance will be when the resistors are connected in series and parallel. Then why late? Hi, this is Santhosh Kumar. Welcome to my channel Sims Academy. Here, today we are going to learn about the resistors in series, in parallel combination, and both we shall see some numericals and also circuits too. Okay, first of all, let us go on to resistors in series. In the part 2, I have told you about the instruments which measure electric current and electric potential difference. Electric current is measured by an instrument called as ammeter, and electric potential difference is measured by an instrument called as voltmeter. And how should they be connected in the circuit? An ammeter should always be connected in series in the given circuit, and the voltmeter is always connected in parallel with the given resistor in the circuit always. Why are we connecting like that? One important thing we have to keep in our mind here is that in series connection, in series combination, current always remain constant. Current always remain constant, and voltage is divided among the given resistors. What happens in series combination? In series combination of resistors, the electric current remains constant and the voltage is divided among the given resistors. How do we say the resistors are said to be connected in series? Let us first of all, this is the symbol for resistance. Consider 3 resistors, let us say R1, R2 and R3 are connected in series. In series in the sense positive, negative, positive, negative. The positive terminal or the positive terminal of the second one is connected to the negative terminal of the first one, and so on like this, positive, negative, negative, positive, negative, positive. If it continues like that, then we say the connection to be in series. This is a series combination of resistors. As I told you here, in series combination, current always remain constant. Let us assume a potential difference of V causes a current of I in the circuit. A potential difference of V causes a current of I in the circuit. Now let the total resistance or the resistance of the combination, we say it as equivalent resistance or effective resistance. Let us say it as Rs. S indicates when resistors are connected in series. Okay. Here the potential difference of V is applied. It causes a current I, where the effective resistance we considered it as Rs. Now we are supposed to find the value of Rs. In the previous session, we remember Ohm's law, the mathematical representation of Ohm's law, V equals to IR. V equals to IR. Now coming to the total resistance over here, for this individual resistance, as we discussed, the current remains constant in the series combination of resistors. Current is I in all the resistors, because in series combination current always remains constant. Then what about the voltage? As we have said previously, voltage is divided among the given resistors. Okay, let us say here the voltage is V1, here is V2, here it is V3. As we said, the total voltage V equals to V1 plus V2 plus V3. Now, from Ohm's law, we get V equals to I into Rs, total voltage, and V1 equals to I into R1, V2 equals to I into R2, and V3 equals to I into R3. V1 equals to I into R1, V2 equals to I into R2, V3 equals to I into R3. Why I am taking only I in all these resistors? Because in series combination of resistors, the current remains constant. Hence, as we said, what is V? I into Rs equals to I into R1 plus I into R2 plus I into R3. We shall take I as common, then we are left with R1 plus R2 plus R3. I gets cancelled, implies Rs equals to R1 plus R2 plus R3. That means when two or more resistors are connected in series, when two or more resistors are connected in series, the effective resistance, or we even say it as equivalent resistance of the circuit, is equal to the sum of the resistances due to individual resistors. Suppose we have three resistors of each of 2 ohm, 1, 3 ohm and 4 ohm are connected in series, then their effective resistance is Rs equals to 2 plus 3 plus 4, it is 9 ohm. Got it? Yes? Okay. Now we came to understand that in the series combination, the current always remains constant, but the voltage is divided. And finally, the effective resistance in case of series combination is Rs equals to R1 plus R2 plus R3. Rs equals to R1 plus R2 plus R3. Now, what about the parallel combination? Parallel combination in the sense all the positive terminals are connected at one end and all the negative terminals are connected at one end. How is it possible? It is possible like this. Plus, minus, plus, minus, plus, minus. This is R1, R2, R3, three resistors. Now let us say this end as A, this as B. A potential difference of V causes a current of I in the circuit. Let the effective resistance in case of this, which combination is it? The parallel combination. Let us mention it as RP for our convenience, because we write in series combination Rs equals to R1 plus R2 plus R3 and so on. Now Rs indicates, we can easily remember that Rs equals to R1 plus R2 plus R3 and so on. Now coming to Rp indicates it's the parallel combination of resistors. Now in case of parallel combination of resistors, in series combination current remains constant, in parallel combination voltage remains constant, but current is divided among the given resistors. That means in all the three resistors the voltage remains constant. How much is the total voltage of the circuit? It is V. Here also V. Here also it is V. But the current is divided. That is the total current, if it is I, let us say in the first resistor current is I1, second resistor I2 and third resistor I3. Now again coming to the Ohm's law, V equals to I into Rp, parallel combination. From here I can write I equals to V by Rp, total current equals to voltage, total voltage by Rp. And here in the first resistor, what is the current flowing? I1 equals to V by R1. In the second resistor, the current flowing I2 equals to V by R2. Third resistor, the current flowing I3 equals to V by R3. Why we are keeping only V in all the resistors? Because in the parallel combination of resistors, always the voltage remains constant. The voltage always remains constant. Now, as we said, the current is divided among the individual resistors. Okay, I equals to I1 plus I2 plus I3. What is I? V by Rp equals to V by R1 plus V by R2 plus V by R3. V by Rp equals to, if I take V as common, then we are left with 1 by R1 plus 1 by R2 plus 1 by R3. Let us cancel V on both sides. Now we are left with 1 by Rp equals to 1 by R1 plus 1 by R2 plus 1 by R3 and so on. That means when the resistors are connected in parallel, when the resistors are connected in parallel, the reciprocal of the effective resistance or equivalent resistance is equal to the sum of the reciprocals of the resistances due to individual resistors. 1 by Rp equals to 1 by R1 plus 1 by R2 plus 1 by R3 plus 1 by R4 and so on. Suppose we have only two resistors. 1 by Rp equals to 1 by R1 plus 1 by R2. Let us take the LCM. R1, R2, here we get 1 by Rp. I can write it as R1 plus R2. Invertendo, if I apply, Rp equals to R1, R2 by R1 plus R2. Direct formula we can apply if we have only two resistors. That is, if we have only two resistors, Rp equals to R1, R2 by R1 plus R2. And if we have more number of resistors, 1 by Rp equals to 1 by R1 plus 1 by R2 plus 1 by R3 plus and so on. Now we came to understand what is equivalent resistance when the resistors are connected in series combination and also in case of parallel combination. Now, how to solve the numericals? And even we came to understand in series combination of resistors which remain constant, current remains constant. In parallel combination of resistors which remain constant, voltage remains constant. In series combination of resistors which is divided among the individual resistors, voltage is divided. In parallel combination of resistors, which is divided among the given resistors? Obviously, correct. Okay, let us consider a small circuit where we have let this be R1, R2, R3. Now we are asked to find the effective resistance between the points A and B. Okay. Given R1 equals to 2 ohm, R2 equals to 3 ohm, R3 equals to 6 ohm. Let us suppose. Now, for better understanding, we can give plus and minus. We can clearly understand that R2 and R3 are connected in parallel, and this combination is connected in series with R1. Okay, let us find the equivalent resistance of these R2 and R3 first. When we have only two resistors, we can directly keep Rp equals to R1 R2 by R1 plus R2. In the sense here, R2 R3, what are those two? 3 into 6 by 3 plus 6, 18 by 9, that is 2 ohm. Now, the effective resistance R effective or equivalent equals to, because R1 and Rp both are in series now. Yes, this is R1. This is the equivalent resistance of R2 and R3. This is Rp, this is R1. These two are in series combination. In series combination, the effective resistance is equal to the sum of the resistances. That is Re equals to R1 plus Rp. What is R1? We are given R1 as 2 ohms, and Rp we got it as 2 ohms. 2 plus 2, it is 4 ohms. Hence, the equivalent resistance of the given combination, we have taken the combination of both parallel and series here. Both, as I told you. Okay? I hope you understood this. What is the basic mistake that our students do while calculating the resistors? Effective resistance in case of parallel especially. Suppose we are given R1 equals to 2 ohm, R2 equals to 3 ohm, R3 equals to 4 ohm. Suppose we are given like this. We are asked to find these three resistors are connected in parallel. We apply the formula. As we know, in parallel combination, we have three resistors. 1 by Rp equals to 1 by R1 plus 1 by R2 plus 1 by R3. 1 by Rp equals to 1 by 2 plus 1 by 3 plus 1 by 4. LCM of 2, 3 and 4, 12, if I am not wrong. 2 6 times, 1 6 times 6, 3 4s, 1 4s 4, 4 3s, 1 3 is 3. This is 13 by 12. In general, these kind of questions are being asked as objective. Objective in the sense multiple choice questions where we are given the answer in one of the options as 13 by 12. If we take that answer, it is absolutely wrong. Because here we calculated the value of 1 by Rp. I got 1 by Rp as 13 by 12 and the value of Rp is 12 by 13. 12 by 13 ohm. In the options, we will be given these two compulsory. Two options will be given, but as we move fast, generally we take this answer which may go in a wrong manner. Okay? Hope you understand this. Okay, let us take one more example, a small example, where this problem was given 3 years back. Now we are asked to find the effective resistance between A and B. It is given as 3 ohm, 3 ohm, 3 ohm. In case of such kind of questions, just we have to mention from here it is being started in the sense the current moves like this, plus minus plus minus plus minus. If I rearrange it properly, we can observe these three are connected in parallel. These three resistors are connected in parallel. Yes, all positive terminals are connected at one end A, all the negative terminals are connected at another end B. Hence, these three are connected in parallel in the sense we apply the formula 1 by Rp equals to 1 by R1 plus 1 by R2 plus 1 by R3. 1 by Rp equals to 1 by 3 plus by 3 plus 1 by 3. 3 is LCM, 1 plus 1 plus 1. I forgot one. This is 3 by 3. It is 1. Which value I got now? 1 by Rp. In the sense Rp value here, it is 1 ohm. Coincidentally, both the answers are same here, but not in case of all the other problems. Okay? This is the resistance when connected in parallel. That means we should observe it carefully. We should understand whether they are connected in series or parallel by giving the signs for the given resistors. We can understand them very easily. Yes, hopefully, and I expect you people understood about the series combination and parallel combination of resistors, resistances. The substance which possesses the property of resistance is called as resistors. Okay, series combination of resistors. When resistors are connected in series, Rs equals to R1 plus R2 plus R3 and so on. And when resistors are connected in parallel, 1 by Rp equals to 1 by R1 plus 1 by R2 plus 1 by R3 and so on. And if only two resistors are connected in series, just we can use this formula. Rp equals to R1 R2 by R1 plus R2, which simplifies because we may do mistakes. As I told you in case of previous problem, we get the value of 1 by Rp first, then while going fast we may forget, yes, to convert it into Rp. Hence we apply the direct formula in case of parallel combination of resistors. Now in the next class we are going to learn about the Kirchhoff's laws, junction law or current law, and mesh law or loop law or voltage law, and about the electric power, if possible some numericals. Hope everybody you enjoyed this session, and we are going to meet again in the part 4 of the chapter of electric current. And this is Santhosh Kumar from SIMS Academy signing off. Stay safe, stay home.